All right. So first off, I want to talk about the bay. I see Eric's made it down. Thank you, Eric, for joining us down here. So I don't know if you can see this, and Eric, you may want to bring the camera in to see the H-shaped configuration of this pit. This is our Baymax 14,000-pound lift, and it is flush mount configuration. It has a specific tabletop in the middle, and we'll talk more about what that does for you and your shop. But then at the end of the day, we want to really talk about, you know, this is North American made lift. It is ALI certified. It's the only lift on the market that's really designed to help maximize the bay space, not only perform in alignments, but give you more opportunity to reposition the vehicle within that bay to get ADAS calibrations performed and calibrated correctly. So again, this is it, and in the upright position, it is full featured, meaning it has a lighting kit. It has heavy duty jacks that have a 5-year warranty with them. Nice powder coated finish. It has extra layers of protection on it so it doesn't rust. So if you're up in the up north, it's not going to rust out on you. Our competition's lift is made in Mississippi. They don't do this, and so those types of lifts up in the north, actually there's a lot of rust that accumulate, and they also have different jacks that are not as good a quality as the heavy duty jacks that we do have on this lift. So at the end of the day, I wanted to really show what this is. The tabletop's in the center. We have a control on our stand over here that moves that up and down. And what that is for is to keep a level surface so I can walk in between nice, without dropping down, without hitting my head. Gives you a nice surface to really work underneath the car, perform the repair. And then when we lower this particular rack, we got our jacks in the center, and then we're able to, because of the concrete configuration, maneuver this car left, right, back, front within that bay space that we do have, give us more space to be able to perform these calibrations that are really needed. So at the end of the day, we're really trying to just create an environment that's going to help your workflow, keep it in the bay where if you can, and complete the job and get it done quickly. Okay. I'm going to lower the rack at this time. And what we'll do is we'll start the process once we lower this of how we start the alignment function. And then, how does diagnostics fit into all this, why it's so important, what we do, why we do it. We'll show you the step-by-step procedures on how quickly we can pull it all together.
Stuart was mentioning this Baymax lift not only maximizes your space, but it takes the metal out of the shop, right? So where a 2-post or a 4-post lift might give you some problems calibrating some behind the car ADAS modules, obviously with no metal in the way, we're free and clear to do the work we need to do, and we're ready to go.
Everybody can see this. This is a VCMI that comes with an Ultra tool. If you buy a IA900, it comes with a VCI. This one actually has our scope module in it, but this is how we start our process. So any of our VCIs actually work for this process, minus like the VCI 100, which is not really capable of handling the data load that we're going to put on this box. Okay, so we're going to use this to ID the car, and then we'll start our process. So anytime you would come in to do an alignment, this would be your process to start. So simply plug in, find your OBD2. You're going to turn your key on, obviously, and then we'll jump right into the IA900. You would perform the target placement. These work really, really slick. Let me show you the operation of how these work. It's nice Nice setup. It's all spring loaded. We do have a lock, grips the tire only, and then our targets, all obviously 4 wheels all the way around the vehicle. So as we stick it on the tire, we just get it lined up, lock it down, and we're ready to go. All right, so we want to start from the beginning. This is how the scan tool looks as we have started this whole process. As you can see, diagnostics is the first thing. If you wanted to just do wheel alignment, we actually have a way that you could go that route. Remote expert, we'll talk more about that later, but that's where an OEM tool may be required for any completion of some different repairs that are out there. Service functions. This is our scope module if you have the scope add-on. Data manager, we'll jump into that. I'll show you that's where our reports go. So that there's lots of reports with this tool. Okay. And essentially Maxi viewer, and then this ADAS and wheel alignment filter. This is a great feature. I know Eric showed everybody a little bit of this earlier, but that's on our web. It's also on our tool. Really helps you understand what's needed to complete the repair. Okay. But we're going to jump right into diagnostics. We're going to ID the car. First and foremost, we're going to put in the necessary information. This is a 2023 Toyota Camry, so brand new car. It actually doesn't have a smart key and it doesn't have an electric brake, but it has almost everything else on it for as far as options. Okay, so what this first screen is our topology screen. This is all the modules that potentially are on the vehicle. We want to run a fault scan at this point. If you could see in the top left-hand corner, it does say we're in our automatic selection and we're in pre-scan mode. So what is pre-scan? Pre-scan is we're going to capture the information as the vehicle came to us. We want to document that in such a way that you have the proper information. It's part of, in our opinion, part of your diag procedures that you should do on every vehicle. But what we're going to do is get a full health check. Think of pre-scan, which is a collision term, but think of pre-scan as a full health check of the car diagnostically. Okay, this is a big deal to everybody, in my opinion. You would put in your customer information. You're going to put in the license plate data. This is so that you can pull this report back up later. It's easy to find if you put in the proper information. And then it's going to scan all the modules. So topology does have to be connected to the internet. You really get a nice view of everything that's on the vehicle with this view. And as you can see, the green means the module is fine. The orange means there's actually codes in that module. And then if it's grayed out, it means that that module is not present on the vehicle. Okay. So part of pre-scan, part of doing a health check, what we say the best practice would be you need to attach some photos. As you can see on this screen, part of our pre-test, part of our pre-scan is we want to verify that the vehicle was in our bay. Let's start there. Hey, Greg, smile. We'll add you to the report. Another important thing to do is let's take a screenshot of the dash. Why would we want to do that? Fuel, mileage, we're documenting everything, okay? There's actually a spot here where we can add just the fuel. You want to look at the fuel gauge. You've just documented it on our report. If you want to put your tire pressure in at this point, you can do that. You want to add a picture. Let's say there's damage on the wheel right here. You can do it. Add it into your report. Okay. All right. So now that we've done documenting the vehicle, what we want to do is we want to back out of it. When we back out of it, it's going to save it. And when we jump back in, we look at our history. We look at ABC 1, 2, 3, 4. That's what I named this. This would be the repair order of that you guys would normally use. Now we've jumped back in to the diag portion. Again, we'd pre-scanned earlier. Now at this point, it's going to say post-scan. Post-scan means you're able to clear codes. You're able to, this is part of the real repair process. We're not documenting anymore. We documented the first part. You can document later as we perform a calibration. But if you were to perform a repair at this point, needing to fix any of those codes that we found in our pre-scan, this is a great opportunity to do that. Okay. All right, so you want to jump right into doing a wheel alignment. When are you going to do that? Here's the different options that we have on. If you're going to perform a wheel alignment after which condition? Routine maintenance? Has it been serviced or suspension's been repaired? New tires? Is there if the vehicle's pulling? Or if you're needing to do a recommended or required ADAS calibration? Let's just do that and punch it in and see what pulls up. So what this will do is if the vehicle is going to require or need it, then it's going to actually take you through that process. All right, so these are all the different model codes. This would be on the door of the vehicle. So when we look here, let's look at your tag. This is a Toyota thing. So you find your tag, you look at all the different option codes that are on that tag, and we're just going to tell the tool, what is this? I think it's the first one, and that what it is we looked earlier. It does have 19 or 18-inch wheels on it, I believe. So this is asking for tire type, and then we're just going to start our procedure right at this point. Okay. Now it's going to initialize our camera kit. So tread depth inspection. If you wanted to go ahead, add more photos to your report, if you want to add all the condition of your tire, you could do it right here. We actually have two tools that integrate into the IA900. The first one is the TBE 200. It's a tire tread depth tool. When you perform the tread depth measurement, it automatically populates all that data right into the report. There's also the tire pressure. When we look at tire pressure, that would be the ITS 600 tool. It's a TPMS tool, a reset tool. But as you utilize that tool to each of the TPMS sensors, it populates the tire pressure data for you. So now you've got verified repair, and you got connected tools that assist and make the job easier. This would be your normal chassis inspection. So if you did find, a loose ball joint, if you saw whatever that needed to be performed, you could notate it obviously on this chassis inspection report. And then we're going to jump right into performing a quick alignment just to show you how the calibration works, or the compensation works, excuse me. Again, everything is going to be menu driven with our tool. It's going to show you the procedure, how to do it. Anybody that can read and follow steps will be able to do this. It's not hard, I promise you. This may look like it's a very complicated machine. At the end of the day, we've got it set up in such a way that it's very easy to follow. Right now, the cameras are going to look for the targets. Obviously, the vehicle is clear down. If the vehicle was up, as soon as it sees the targets, the boom stops. The next thing that we need to do, we're going to perform a rolling comp. The vehicle does have to be in neutral. So I'm going to put it in neutral. I'm going to let Big Bear over here do the rolling comp. Eric. So go forward. Stop. Okay, back. Push back forward, back to center. Lock your tires so it don't move. And then we jump right into the next step. We're going to do a caster sweep is the next step. You also could do maximum steer angle. What that is, toe out on turns is the other one. You would be performing it clear to the right at full lock and clear to the left at full lock. We have wide angle targets that have to be put on the front targets to perform that. Think of that as a full blown you're blueprinting the chassis for collision work. If you wanted to really get extra data and ensure that the frame is totally squared and everything is set to go, you'd add the wide angle targets. You would do the max steering angle in order to do that. We're going to do a basic caster sweep. It's going to be at 10 degrees. So not full to the right, not full to the left, but only 10 degrees. And go ahead, Eric. We're going to start this process to the left first. So go to almost 10 degrees. There you go. Now go back to the right. Okay. And back center. Great. So as Eric backs out, now the camera can see all the readings. We have our thrust angle, which is just barely really over the threshold. You want this really to be 2 and under if you can. Obviously 0 is perfect for thrust angle. But the rest of our readings, we do have, looks like a little issue with some of the toe. But that's okay. We got a quick reading. All this again will be menu driven on the right side. If you want to look at just the rear, this would be the rear section. If you want to blow up and look at that section, you can. If you want to see how to do an adjustment on that, or if there's any special tools required to handle this, then it'll be in there. Like this here, there's an eccentric bolt. It'll show that. Procedure, short little video. So nice graphics that help the technician, finalize the repair. This is just the front. This would be, go ahead and center the steering just a little bit. It's going to be very small. Okay, so what this is, after Eric steps back a little bit, is all the chassis dimensions. So this does give a full value of wheel setback, cross diagonal measurements. If there's any chassis issues with the vehicle, it's going to show up right here. So nice specs here that really help you with the repair. And then the last one will be your actual tire diameter. Nice little screen here to let you know, hey, all the tires are the same height or they're not, and obviously this could probably point you pretty quickly to a low pressure in a tire, but hopefully you've already done that step in the beginning. Okay, so we'll save our measurements. Now the next part would be just walking through the actual repair. If you need to do adjustments, that's what these steps are. I'll breeze right through them because we're not going to do any adjustments today, but just to let you know, this is how it looks. If you wanted to do your front camber, here it's going to be all greened in. You start performing the repair or adjustment. Same way here, if you needed to do caster, obviously you could do that adjustment. Front toe, and then we'll have some results here shortly. Now this is our toe function. So if you want to center the steering wheel, it is a specific software that helps center the steering wheel, left and right side. There are procedures here that helps blow this up. We get the steering wheel exactly center in the right spot before the vehicle goes off the rack. Okay. All right, so these are the next procedures. It's, as you can see, we went through a wheel alignment. This actually has 3 different steering angle relearn procedures. But I wanted to show you that it's in this vehicle for a 2023. This shouldn't be an after the fact. The car is already out of the bay and you do a steering angle relearn. It's actually should be done right now in this particular circumstance. And as you can see, you got sensor 0 point clear, you got sensor 0 point calibration, and then your power steering system calibration also. Also, just wanted to show this real quick. If you want to see the targets from your cameras, that's what this view is. What's cool about this is if this is in the green, you know that we're seeing the target correctly. All right, so ignition power switch is on. It should be in park, Eric. So let's make sure it's in park. I think it is in neutral at this point. Okay, so the scan tool is looking for the steering sensor input. As you can see, we reset the memory. I'm going to hit just a quick snapshot of that. We're going to plug that into the report for later. We're going to jump right into the 0 point function. Your yaw rate sensor is 0. The SAS has been reset here, but that's only step 1. Okay, so now we got to go ahead and do the next one. So read the instructions, make sure that obviously everything is zeroed out. Your brake pedal depressor has already been removed. Ignition is on, engine is off, and the VCI is plugged in. All those things have been met. We want this to be as close to 0 as you can get it before you start the repair. We're at 0.1. It's really, really close. It's going to go through this procedure, and it should be doing the calibration. Okay. That says it's been successful, and should be the last one here. Again, read the instructions. That's the key to all this. Just read the instructions. Make sure that you want to see if the power steering lamp is on. Eric, real quick, per the instructions. Yes.
Yes.
Good. Sure, the steering wheel is center, because we're about ready to do the final calibration to the steering angle relearn. Okay, it says center the steering wheel, turn the steering wheel wheel to the left or right, 45 degrees. Turn the steering wheel left, 45 degrees. Keep going. Okay. Back off. Now, back to the right, 45 degrees. Keep going. Keep going. Whoop. Now go back to center. Okay. All right, so that procedure right there, if you was on a factory scan tool, that's the exact same procedure that would be in TechStream Live. So that's not our procedure, that's the OEM procedure. We're following how the OEMs want it done, and we're able to access the module and perform this calibration. If you guys aren't doing this one today, that is 3 separate calibrations that should be charged for. That, in my opinion, is 3/10 to half an hour for each one. That's a lot of labor time that you guys could be collecting today. Complete. Erasing the codes. Succeeded. Awesome. So we've performed a proper alignment diagnostically pre-scan. We performed any adjustments hopefully that was needed, and we performed the steering angle relearn procedures that is super crucial. So what's the cool part here is now we've tied all this stuff together. We have nice reports. If you want to see how the reports look, obviously before and after everything should be green if actually did the alignment properly. Any of your current values on this report. The symmetry will be on one report, so you could see in any of the chassis issues if there was one or was any issues. This could be part of your chassis report. We didn't enter anything into this, but here you would see what was wrong during the chassis inspection report. This, if I would have done any of the tire data, it would have showed up here. So nice report that shows all of the different report that to the cloud, select all. So any of the tire reports would be there too. So great stuff to really help you sell more services. If you wanted to print, obviously we could do this to any printer that's on your network. We could do that. Okay, so we're going to exit out. Now, let's jump right into a cal. So as we performed the alignment, let's jump in and we'll do a quick fault scan of just the ADAS modules. And what'll happen here is it'll line all these up. If there's any codes in any of the ADAS modules, they'll pull up here first. And then you'll be able to see to the right, you see the little bullseyes. That means you're able to calibrate something in that module. Okay, so let's let the scan tool do its thing and see what comes out of this. But let's go ahead and jump in and let's do this front recognition camera. As you can see, if Eric, you could go right into that mirror up top there, and let's show them what a forward-facing camera is. Right here in this section, right behind the rear view mirror, this is part of preconditioning on any vehicle. Always look right here. Is there a camera in the windshield? If there is, you know that more than likely when you're performing an alignment, you need to be doing the calibration to that also, okay? On radar, what you'll see is a lot of times in the front, you'll see the little plastic in the front of the grill. You look for that piece of plastic, there's a radar module behind that. Here's our calibrations, dynamic or static. Let's do the static so that we can show you how this works. I'm just gonna click why we're doing it right here. This will pick the two different targets that are available. The first one is what they call a one-time recognition target. That does all three positions in one swoop. The second one is a single recognition, meaning you got to go to each step. This particular vehicle can do both, so that's why it's in there. Typically, the later model Toyotas will do one-time recognition, just for your reference. We're going to use the single because I wanted to show that process. This is, you're going to pick what type of circumstance you're on the floor. Is it an unlevel floor? Is it a level floor, or are you on a rack? We're on a rack, but we're level with the floor, so we're going to pick A. This will tell you what do you got to have in front of the vehicle before you start. Obviously, these are the tools you're going to need to do this calibration. The area. This is the calibration prep, okay? So full tank of gas. This is what the OEMs are asking for. Make sure the spare tire is in the trunk, okay? Turn off the headlamps, close all the doors, and make sure the tire pressure is adjusted, right? So read these instructions. The preparation is key. We have a lot of shops that do bypass these steps. Really follow the instructions. This is coming from the service information from the OEMs. They're not our instructions. We're taking that from the OEM.
Clean the windshield. I see that one.
Clean the windshield, please. Yes. This is setting up our frame, is essentially what we're going to do here. Unfold our crossbars, which we already have. We're going to position the frame in front of the vehicle and so forth. This really tells you about what do these knobs do. You're going to zero out all these knobs, and we'll talk about what yaw means and the role and what all these adjustments actually mean. Distance, targets to the wheel, and then we're going to jump into doing a calibration here shortly. All right, so the first step is we want to know the distance from the front of the car to really our camera, which is right there. You got it?
Go for it.
Okay. So we're going to line this up to the front of the vehicle. We're going to hit next. If you saw that, what it did is this camera looked at this target. Now it's calculated the distance. So that's the very first step that the tool needs is we need to know the exact distance from here to our cameras. Now that we've taken that first measurement, we can jump right into the next piece. So this is about moving the calibration frame in this target here into the proper spot. As you can see, this is front and back. We're at 1183 millimeters. We need to be at 1150 or close there to it. Eric, do you want to zero us in? So we position this frame and get it centered real close to that 1150. Just pull it back a little bit. You're 10 millimeters. It's not very much. There you go. Perfect. So get this within 10 millimeters of that target. You're going to see that if it's in the green, we know we're good. We're going to lock it. And now we're going to adjust our angle and our offset. And there are adjustment knobs up here that's going to adjust this camera boom just right. We're going to adjust this target exactly where it needs to be with the front of this vehicle. That's what this procedure is doing.
Pretty simple though. It's telling us exactly which way to turn that knob, which knob to turn.
You can get it closer now. Go a little more. Keep going. Get to like 5. There you go. Now we got to do the other side, which is the lower one. Turn to the right or left, I'm sorry. Get that in the green. We should be good. So
0.
All greened out. That's perfect. We hit our next button. We're going to go on to the next. Okay. This would have been pitch and roll. As you can see, we're in the green already. To adjust that, you would be going at the very top. You do this roll and that pitch angle on the other side. But we're already in the green. We're really, really good. We're going to hit next. We want to make sure that this isn't flickering around. If it is, that means everything's moving just slightly. This will pick up the minute of movements. So this is really a crucial step of this calibration. Just make sure it's not moving around. As you can see, we got this target, the 60115 target. We've already got it added to the front of the tool. We're going to start in the middle. It's taking the position right now. That's what it's doing. Is it's letting the car know, hey, that target is in the center. And now when we hit start, what this is going to do is put this at the right spot. So the spec is 1350. See where the camera is, how high that camera is in relationship to the windshield. We got to get this target at 1350 so that it's in line with that camera. That's what these specs are really doing. If you really look at what's happening here for this calibration, it's as simple as that target's got to be at the perfect level, 1350 millimeters with that camera, and we're going to start the calibration. Again, automated. There is no manual up and down. The 900 does all this automatically.
Very conversational instructions, very detailed, follow the instructions.
These are the actual OEM specs that populate automatically based on the vehicle. As you can see, there is a way to change them. We'll talk more about what that means in the future and being able to change values. But today we're using the OEM values. We don't want to move. We don't want to change anything. Okay. Okay, we're in the center. It should take this measurement, and then it's going to ask us move it to 550 millimeters on the driver's side. Up top here is a measurement. It goes clear up to 1210 millimeters on each side. We're going to go to 550, and you center it and you zero it and you hit OK. And now we're telling the computer in the car that's where this target is, 550. And then our next procedure will be 550 on the other side. Okay. It's successful. We'll screenshot it. We're done. So with that being said, this particular vehicle, we've went through setting the calibration. Now we're going to perform clearing all the old history out of the module. The reason this is important is after this calibration, the car is actually, if you notice, it has a dynamic function. It's going to try to even fine tune it even more. We want to clear all the old stuff out. And that's what this function is doing here. Rob history is an OEM function, and very few aftermarket scan tool companies can actually perform this. Matter of fact, I think we're the only ones that can currently on Toyotas. But we just finished this calibration pretty easily. That's a $350 job plus, depending on, what part of the country you're in. We're not telling you, obviously, what to charge, but on average, that's about what that would run. Wanted to just kind of walk through, here's the basics of, alignment, how this diagnostics is so important on the front side to really uncover. You notice this is a 23 car. It's got a ton of codes in it. And so there's a great opportunity to get more out of this particular vehicle, even a 2023. Perform the alignment, perform the calibration, really do the right job, get this all onto the reports, get it to your customers, charge for the service, really have an awesome experience for the consumer.